Assalamualaikum warahmatullahi wabarakatuh. Good morning. We are from Group 4 and we would like to presenting the high-rise building with the title is Marina Bay Sands. With the member are first Muhammad Rahmanda with the student number 2005236292230. Second member is Muhammad Ferdian with the student number 20052362937. And the third member is Muhammad Hafiz Fikri, 200523629226. Okay, the first we are going to Muhammad Ferdian to explain the slide. Fer di unmute dulu Fer. Itu mic-mu masih mati Fer.
Sorry Nek. Tak kira tadi nyala terus ya. Oke.
Ini diulangi dari awal atau gimana? Ulangi aja wes biar nggak capek nanti ngeditnya.
Itu dikat pas tengah-tengah
Sorry ya,
bisa
Dek.
kayak
Apa?
dikat dipotong kayak bisa.
Oh ya udah nggak apa-apa. Oh ya udah. Lanjut.
Okay, the first I will introducing the building. The name of building is Marina Bay Sands. The Marina Bay Sands is an integrated resort and sky park fronting Marina Bay located in 10 Bayfront Avenue, downtown core of Singapore. Marina Bay Sands built as the world's most expensive standalone casino property. Marina Bay Sands was designed in 206 and was built in 206 until 210 and opening at 23 June 210. Design of Marina Bay Sands, the architect is Mushi Safdi, landscape architect is Peter Walker, engineer is Van der Weyl, the structural engineer is Arup, construction company is Basi Soletans, and the developer Las Vegas Sands Corporation. The Marina Bay Sands provide hotel with 2.560 and hotel with and there are sky park, convention center, shops, restaurants, two theaters, museum, a casino, waterfront, boardwalk, and etc. And this is the facility of Marina Bay Sands. There are casino, shopping center interior, the rain Oculus, and swimming pool. The building design of Marina Bay Sands, this tower initially inspired by card decks. The prominent features of the design is the three hotel towers. The three towers are broader at the base and narrow as the rise. Each order was to asymmetric lights with a curve strength like leaning against the other, creating a significant technical challenge in its construction. With its 3,040 meters long, 40 wide, and an overhang of 65.92 meters at a height of 198.12 meters above ground level. The Hotel Terrace Sky Park is the longest live and observation deck cantilever world and has become a symbolic icon Singapore. There are many transportation you can use to go to Marina Base. There are LRT, bus, and water taxi. The reason why we choose Marina Bay Sands is unique design, multifunction building, and luxurious interior. The structural system of Marina Bay Sands is using hybrid system for the structural system tower, which 2,000 meters high with 55 floors in each tower. An advantage from the Marina Basin is electricity is still there even during the blackout. Maximus maximize the reduction in electricity bills, re- reduce maintenance and efficiency with durability. And there are no disadvantage of Marina Basin's sky park roof is support structure of the roof is IWF steel with 1.5 meter thickness and 4 until 10 meter length based on Singapore standard BS 5,400 and BS 5,500. Meanwhile, it used fabrication steel frame with 4 meter cavity area, hollow steel shape for the cantilever based on the same standard. Sky Park Belly is the structure that use our steel frame structure covered with silver painted metal composite panel. Sorry, kok langsung entek. Okay, and the next slide will be explained by Muhammad Hafiz Al Fikri.
Okay, next I will explain about the footing. The footing of the Marina Bay Sands Tower is using board pile with 108 1,100 millimeters or 1.8 meter until 3,000 millimeter or 3 meter diameter. The depth of footing are 69.5 meter to 92.5 meter. Next. So this is the facade material of the towers. In the west side, we have the glass materials, and in the east side, there are structural exposed on the wall of the towers. Next. Next is the shear wall. The shear wall represent a structural efficiency solution to stiffen a building control system under natural loads. The main function of a shear wall is to increase the rigidity and strength of the building for lateral resistance. And unlike other high-rise tower buildings, the primary lateral stability demands is not wind but is gravity loads. the curve creates overtuning forces. Next. So this is the forces of the building towers. There are the axial forces, the shear of the shear wall forces, the deflections that might cause by the wind or any other kind of things, and there are the moments to the ground of the forces. Next. There are many innovations of using of in the there are many innovation using in Marina Bay Sands Tower. The first one is booster regenerative elevator. They are the elevator that reduce 40% energy for the elevator. So there are 60% energy using the elevator. The second one is automatically escalator. The third is waste separator. The fourth is automatically air cooler. The fifth is convex and concave room, and there are many things. So the Marina Bay Sands have got many trophies for the green building trophies. Next. So this is the section through complex of the Marina Bay Sands group. There are the towers, the casino, the Bayfront Avenue, the roof garden, the waterfront promenade, and others. Next. So inland carry Singapore that meant going underground, including the first one is water electrical tunnels. The second one is pedestrian and commercial spaces. The third is transportation infrastructure like highways and subways. The fourth is telecommunication superhighway. Okay, next. This is the three graphics of the Marina Bay Sands group. The in the up in the upside we have the 3D graphics of the towers, and in the downside we have the towers and all of the Marina Bay Sands group, including the theater and the casino. Next is the substructure. The substructure of the Marina Bay Sands. The purpose of the substructure. The first one I would like to tell about the substructure. The purpose of the substructure of a building is to transfer the loads of the superstructure to the soil that is underneath. This is why the substructure is raised against the soil that supports it. Now it is important that you spend the working with structural engineers to ensure that all supports, beams, columns, and foundation are incorporated properly to ensure that nothing will collapse within the substructure. Most of the time, the substructure is made from plain cement concrete or reinforced cement concrete. When that is in plain, stones, bricks, or additional concrete is added until it all reaches the plinth level. It is necessary for a damp-proof course to be laid on top, so that moisture doesn't penetrate any part of the substructure. Okay, next. So this is the major structural design challenges for the Marina Tower. The first one is building on reclaimed land, which is soft and very wet. The second one is the design of the tower is flaring out. The third is creating a sky park on the top of three separated towers. So in the in the three separated towers, there are a cantilever of the sky park. Next. So this is the sketch overall for the building towers of the Marina Bay Sands. There are windscreen, sky park, and the others. Next. The tower of the Marina Bay Sands. That they are the three towers are border at base and narrow as the rise. Each tower has two asymmetric legs with a curved eastern leg leaning against the tower, creating a significant technical challenge in its construction. Substantial temporary structure were necessary to support the legs of the tower while they were under construction and required real-time monitoring for continual assessments and analysis in the course of their erection. Next. So this is the circular diagraph walls for minimal strutting. The walls is locations in in the red one, and cutting of the diagraph wall exposed about excavation level. So the deep excavation were required across the site, with general excavation depths ranging from 18-meter to 35-meter underground. Parts of the diagraph walls of the two tower to the two hotel cover dams doubled as permanent hotel basement walls and lot bearing elements for the hotel towers. Next. And this is the DCS box. The resource diagram shear walls for the DCS box. The shear wall constructed with the DCS box enable unhindered bulk excavation across the theater area to the west. The DCS box also doubled as a retaining structure for the deepest excavation in the adjacent cut and cover tunnel where a deep valley of submarine clay is present. Next. So this is the shear and end bearing reaction from old alluvium acting on the DCS shear walls. So there are the elevations of the shear walls, and there are a lateral force from the first one slab and the lateral force from the second slab of the B2M. On the right side we have the DT side, and the west side we have the trader side. Okay, next. So there are the loads of within the towers. The first one is the dead load. The dead load was calculated summing all of the materials weights. All of the materials were recorded for this building. However, we did have to assume something such as the stainless steel used in gauge 16, which is most common. The second one is lift load. The lift load was calculated using the assumptions that the building is a commercial building with 100 PSF of lift load. This number was multiplied by the total square footage of the building to get the final lift load. The third one is horizontal load. The horizontal load was calculated by multiplying the assumed wind lift load in PSF and multiplied by the side of the building with the greatest surface area. The assumed wind lift load was 15 PSF for winds 130 mph, which was close to maximum wind speed recorded in Singapore during a typhoon. And the last one is the foundation load. This is the sum of the dead and lift loads calculated. Next. So what is the solutions of the Marina Basin's problem? The first one is the building on the reclaimed land, which primarily consists of sand and fill on that deep submarine bay deposits was solved by using very deep piles up to 80 meters deep and circular shaped cover dams made of reinforced concrete with dry enclosures along with concrete slabs for the building to sit upon. The second one is to solve for the towers that flare out. The building has reinforced concrete shear walls, and at the intersections there is a steel truss system that holds the tower into place and resists over-tuning forces. The third one is to solve the problem of creating a sky park on the top of the three towers. The tower itself is made to be lightweight, where the body is made of the aluminium and is held up by steel trusses, creating many voids. There are also moving seismic joints connecting the sky park to the towers so that they may move freely in case the towers are moving. Okay, the next slide will be explained by Muhammad Faramanda.
Upper structure. The structure that located above the ground include the wall, floor, the edge. Next, floor system. In flat slab post the this Astaghfirullahaladzim. Floor system. In flat slab post station max span and of 10 meter. Mixes the structural efficient and is the simple floor structure that aids in the build time. Accommodation the floor to floor height. Next, Rain project to the share the walls. Rain project concrete shear wall in the ward direction, primary, vertical, and the traverse structural system. Next, next, hotel atrium walls. Concrete between all three towers. Ground level with the declines from south to north direction. Hey, the races from south to north direction. Next, framing of the steel structure connected by horizontal transoms in the state with glass panels, rectangular hollow certain areas or the main structural members. The temporary system comprised of steel compression and tension cable during construction. Next, this is the main lobby of the hotel. Next, this is the construction element of the hotel tower between first tower, second tower, and the third tower. Next, this is the construction element of the cantilever. Next, construction question. Next,
Play videonya, Per.
play video.
So this is the Marina Bay Sands facility, including the Art Science Museum and more. So there are many luxurious interior in Marina Bay Sands. There are many shopping centers and theaters and others. So the Marina Bay Sands is known as the biggest casino in the world. So this is the how the towers was built. This is the west side of the tower, and that's the how the cantilever was built. And this is the view from above the Marina Bay Sands Tower. There are the pool in the up of the cantilever. So this is Marina Bay Sands, Singapore. Thank you. Assalamualaikum warahmatullahi wabarakatuh. Oke, kelar ya? Oke, dap. Matikan recording. Dah, Rek.